Hello guys. Alright, so today we're going to add with greatest common factoring with terms that have a mix of integers and variables. And this can get quite confusing, so if you need to watch this more than once, you can. I am also going to attach the link for the video that's listed on this page. It'll be with your assignment. It'll be under the one that I'm doing. Alright, so here's a couple examples. The first one is find and factor the GCF. And what they have done is they took 6x squared y plus 14xy squared minus 42xy minus 2x squared y squared. And what they did is they broke it down into individual terms so they can find the common denominators. And so we know that 2 times 3 is 6. And x times x is x squared, and y is just y. 2 times 7 is 14. X is x or y squared is y and y. And then the same with the others. 42, if you did a factor tree, I know that 2 goes into it 21 times. And then I know that this is composite, and I can take that 3 times 7, and now I have 3 sets of prime numbers. And so that's where they get the 2, the 3, 7, and then we have an xy, so it's just an xy. And then I have 2, well, we know it's just 2 times 1, so we're just going to leave it as 2, x squared, xx, and y squared. And then what they did is they took and they circled all the common numbers. 2 was our only common number that we had in all 4 terms, and so 2 becomes part of our greatest common factor. They each have one x, so there's 1, 1, 1, and 1. So x is going to be my common factor there. And then they each have at least one y, so there's that one. Now this is my GCF, okay? This one here, this is my GCF. And I'm going to multiply it by everything that didn't get circled here. So when I'm looking at this one, I didn't circle a 3, and I didn't circle an x. So I'm going to multiply it by 3x. And it was plus up here, so it's going to be plus down here. Then I had, let's see, the next one is 14xy squared. So at this one, I didn't use the 7, and I didn't use this y. And so that's where 7y comes from. And then it was minus 42, so I'm going to put my minus sign here. And for the 42, we did not use, we didn't use the 3. Oops, I'm not going to circle those. We didn't use the 3, the 7, and 3 times 7 is 21. And we did use both x and y, so 21's all that's left there. And then on this last one, we used the 2x and y, so all that was left was an x and a y. And it was minus, so it's minus x, y here. I kind of scrunched that in there. So this is all factored out using our greatest common factor. You could do the same thing going sideways rather than stacked if you like. 8 could be 2 times 4. 4 is not prime. 2 times 2, so we have 3 2's. So that's why they have 1, 2, 3 2's. And then there are 3 x's, 1, 2, 3. And then there's 20x squared. If we take 20 and factor it out, we have 2 times 10. That's composite, so I can do 2 times 5. Now I have all prime. So it's 2 times 2 times 5, and then x squared is x and x. And then 12, if I take 12, I can get 3 times 4. 4 is composite. 2 times 2. So I have 2, 2, and 3. So 2, 2, 3, and then there was an x. And then I can just go through and I can highlight or circle all that they have the same. They each have 2 2's. And we know 2 times 2 is 4. And then they each had, excuse me, they each had an x. So I have an x. So 4x is my GCF, okay? So this is my GCF. And then I did not use a 2 and 2 x's, so 2x squared minus, I didn't use a 5 or an x. And it was add 12x, and we did not use a 3. And there it is, all factored out using your greatest common factor. Okay, let's practice some. So the first thing I have is 16q minus 32. And my two terms are 16q and 32. And so I'm going to factor those out. 16 is 4 times 4, which is 2 times 2 and 2 times 2. So I should have 4 2's and a q. 32 is 8 times 4. That's 4 times 2. So I have 2 times 2. And that is 2 times 2. Oh, let's see. I have 1, 2, 3, 4, 5 2's. Minus 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. 2, 3, 4, 5. Yep, I got them all. And that's something else you want to do is when you have a lot of numbers, make sure you have the right number of them. Otherwise, it'll throw you off. All right, so let's see. We have a 2 and a 2 and a 2 and a 2. So we have 4 2's. We have a q here left, and we have a 2 here left. So our greatest common factor is 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's going to be 16. And then in our parentheses, we had a q left minus the 2. And there is our greatest common factor used to factor out our polynomial. Okay, sometimes you don't have to find the greatest common factor if you can see what the greatest common factor is going to be. In this one, I have 7g4, 21g third, and minus 14g to the second power. And if I'm just looking at these numbers, my greatest common factor of all three of these, 7 will go evenly into each of these. So my greatest common factor in integers is going to be a 7. I have 4 g's, 3 g's, and 2 g's. So they each share 2 g's. So g2. So there's my greatest common factor. If I use 2 g's, I have 2 left. 7 times 3 gives me 21. And I use 2 of the 3, so there's still a g left. 7 times 2 is 14, so I have a 2. And I use both the g's, so that's all I have left. If you can see it that way, you can do it that way. If you prefer lining it all out, and then circling and crossing out, please do so. Do it in the way that's going to make the most sense to you. Okay? Okay, this one is 9m to the 4th power n to the 5th power minus 27m squared n cubed. And I need to find out what my greatest common factor is going to be. And I see a 9 and a 27. And I know that 9 goes into 27 evenly. So 9 is my greatest common integer. I have 4 m's. I have 2 m's. So I know I'm using 2 of the m's. And I have 5 n's and 3 n's. And I know I can share 3. So n to the 3rd power. There's my greatest common factor. 9 times 1 is 9. I have 2 m's left. And I have 2 n's left. 9 times 3 is 27. I had used both of the m's, and I used all of the n's. So it's minus 3. If you need to see it done the other way, This is 3 times 3 times m, 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 n, 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 1, 2, 3, 4, 5, okay? And then this one is 3 times 3 is 9 times 3 is 27, m, m, n, n, n. Ooh, just barely fit. All right, so I have in common 2 3s, and I have 2 m's, and then I have 3 n's. 1, 2, 3. So I have 9 m squared n to the third power times what I have left. I have 2 m's and 2 n's, minus I have a 3, and that's all that's left there. Either way, it really doesn't matter which way you choose if you can see it. If you have any questions, make sure that you contact me via email, Google Classroom, something, and ask me for help. Remember, office hours are from 2 to 3, Monday through Friday. You don't have to attend each one, but just make sure that you are attending at least one each week. And I also have the Remind app. The homework is the 9 questions that's attached to this set of notes. I'll see you later. Bye.